Hello everyone, my name is Anthony Shivkumar, and in this video I'm going to be talking about the Microchip MCP2221A, which is a bidirectional UART to I2C protocol converter. Now, I have designed the breadboard in one of my previous videos, and in this video we're going to get into the details of how to interface with how to get it working, how to interface with a sensor, and then see how the I2C protocol actually works to communicate with the sensor. We will download certain tools that Microchip provides when you are using this particular MCP2221A chipset, and we'll start to write and read data using I2C using the utility provided, and from there we'll also look at the logic analyzer and get into how the data is actually propagated at the hardware level. So let's get started. Now, before we dive into downloading the software and testing the device, let us have a deeper look into the hardware. There are a total of 11 pins on this breakout board. The board has a 3.3 volt, 5 volt, then it has a receive and transmitter protocol for UART, and it's got the two data buses for I2C, SCA and SDA, and ground. It also has 4 pins, general purpose input output pins, which can also be configured for other functionalities like ADC, DAC, etc. So this is the breakout board. You can connect this through to your computer using USB. And at the back there is the SCL and the SDA, and this is the MCP22A chipset. In order for you to use this chip, the first thing we need to do is to go to the Microchip MCP2221A website and download the utilities that are provided. You have the MCP Windows driver and installer, Linux driver information, utility, DLL, SM bus, and terminal. The two important software that we need to download is the utility and the SM bus terminals. These, I think, can only be downloaded on a Windows machine. I have already gone and downloaded both these utilities, so you can install them wherever you want, and here we have them. So I have the MCP utility, and I also have the I2C SM bus terminal. The utility allows us to configure the ports and auxiliary connections and systems, and here we can send the I2C data to read and write. As soon as I connect the breakout board to the computer, you will see it say that that the device will be connected. So what I'm going to do is have this over here and this over here, and here you can see device count is 0 and the device connected is also 0 over here. So device connected and the device count is 0. So now when I plug this in, you can see the device count is 1 and 1 device connected. I am also going to now attach my logic analyzer to the SCA, SDA, and certain general purpose input output pins. So now I've connected all the logic analyzer to the system, and let me try to do some basic configurations. So now I have everything connected. Okay, now that I've connected my logic analyzer, I am going to connect all of this together. And here you can see that there is GPIO 0, GPIO. I can configure this to be an output and certain parameters. So this is the utility, and I'm going to configure this as GPIO, and I'm going to change it from high to low. And the blue pin is basically low, so this is low. So now if I change this to high, logic level high, you will see this change as soon as I click configure device, and now it's changed to high. Similarly, the yellow bar is now set to the second one. So if I set this to low, you'll see this yellow turning into low, and now you can see this going low. So I can again change this to high, and you can configure it to high, and similarly to this to low, and I can configure this to low. So that's one way to configure the GPIO pins. Now let's send some I2C data and see how that goes. So this utility over here called the SM bus terminal utility allows us to send some data. Now I have a sensor in here. I have a sensor connected to this particular chipset, and this is a TOF, a time of flight sensor, and the address is an 8-bit address is 53, and the 7-bit address is I believe it's 39, but we'll check it out. So what I'm going to do is I'm going to play this out over here, and I'm going to zoom out here. So these are the SCL and SDA lines, the black and brown, and I'm going to send in 53 over here and just say a read of the first of register 1, and then I'm going to click send, and it says F0. And let's have a look at the clock over here, the signal over here. And now when we zoom in, you can see that we can see the clock signal sent. We sent in 29 if this is a 7-bit address, and if it's an 8-bit address, it'll be 53. And we received an F0 as a reply for this particular register value. And similarly, I can do a write. I can do a write. So since it's a write, I need to change this to 52 because it needs to be now even. And let's say a write of 52 to the register address 1. We'll click a send. It says OK. And now we'll click stop. And then let's have a look at the I2C signal over here. And here we see that this is the address. The 7-bit address is 29. That won't change. But the 8-bit address is now 52 because this is now a write. And here we just basically written a 1. And here you can even do like device discovery. If you want to scan an address and you don't know what the address is, and say you put in like say 01 to say a range of say 69. And if I play this, you can scan this. So if we do this and then click scan, you will see the scanning all within that range, and it says it's found a slave address at 53 and 53. So you can really do this if you want to scan a bus. So it's a very handy utility to have. And it's found the bus at the 8-bit address is 52 and the 7-bit address is 29. It's a fantastic utility for an I2C and debugging any I2C protocol. To get a sense of what your sensor address is, or if you want to read a particular register and get that value, troubleshooting certain parameters of the register, it's a great utility. That's how I would be using this, so that you don't have to necessarily configure an MCU to send the data and do all of the hardware abstraction layer and write all that code. This is a handy utility and a tool to just debug and see if my sensor is working. And then from there you can program your hardware and your MCU to generate the signals that you want once you can quickly troubleshoot and prototype this particular protocol. So that's really what I had to show today, the overall working of the MCP2221A, how handy a tool like this could be, especially when you're doing embedded systems, working with sensors, anything that requires the I2C protocol. I also have the SPI bus. You want to check out that video, do highly recommend you check that. The link is below. Yeah, until next time, please subscribe if you like this video, please like the video, and until next time, please take care.